Okay, so let's take a look at each of the challenges one by one. So this is going to be code challenge one, and we're going to take a look at it from each of the perspectives identified in the game. So we want to take a look at it from how each of your learners will use the player sheet to write the pseudocode, to write the flowchart, and then to write the coding elements. So let's take a look at this one by one. And in so doing, what I want to do is actually look at the code structure for pseudocode, look at the code structure for the flowchart, and then flow back to uh, actually using Python, which is a text-based programming language, to take a look at the code structure and how it actually executes. And so then you'll have an idea of how to write each of the lines of code in the player sheet. So let's do this one by one and see how this flows, okay? And what we want to do is take this sequentially. So we'll use the basic steps here. And then once we go through all 48 challenges, then we're going to go back and take the next step in our learning. And that's using those coding challenges to write code using the Scratch programming language, okay? So that's how I'm going to flow through each of the 48 code challenges, and we're going to start with one. So the first code challenge right here is to simply add two numbers together. And those numbers specifically are 3 and 4. And what we want to do is ensure that they understand that we're going to use variables. So in your lessons for your students, make sure that they understand that a variable is really just a word that takes the place of something else in their code. Now, this may not seem important right now, but variables are going to be used extensively in any coding language. So we just really need to get that clear to all of our students that there are so many things that we can do with the variables, because one key thing about a variable is its value can change, and that's really important. Because what we'll see is we'll just use three different types of variables for a lot of our code. One of them is called num1 for number one, num2 for number two, and either a sum, difference, product, or quotient. Again, sum for adding two numbers together, the difference for subtracting two numbers, the product for multiplying two numbers, and the quotient for dividing two numbers. So for challenge number one, we're going to store both of these numbers, 3 and 4, into their own variable. And then what we'll do is we'll use those variables to do the math operation. Now this is really critical, and we're going to do this over and over and over again, because this is really how code works in programming languages, okay? We use variables in place of values because we could always change the value. And when we get into tier two of the program, we'll learn that we could actually have the user, whoever's using the program, to actually provide those input values. But right now, what we want to do is pre-populate or pre-assign the values for those variables. So we have a 3 and we have a 4. That also means right now, because we haven't done any math operation, that the variable sum that we'll use has a value of 0. And we're going to see that in just a bit. But what we want to do is change or store the variable sum to equal 3 plus 4, or sum equals num1 plus num2, and then display that on the screen. So let's take a look at this from the perspective of the pseudocode and the flowchart. And this is what it would look like. So in the middle, we have the pseudocode. So the first thing that we always want to do is tell the user what we're doing or what the program should do. So the program here simply should say, add two numbers. Now, if the learner says, well, we want to add 3 plus 4, that's okay too. They get the idea that they're telling the user what the program is going to do, and that's perfectly okay. What we have to do in the code then is to store the values of the variables inside of those variables. So we're going to create two variables, num1 for number 1, num2 for number 2. And then we're going to use the equal sign. That's an assignment. So we're going to say num1 is equal to 3. So anytime I use num1 in my program, I know that the value of that variable is 3. And the same thing for number 2. Num2 is equal to 4. And in this particular program, all we're going to do is add those two numbers together. So we have 3 stored variables, num1, num2, and sum. We then have one action item, and the action item is sum now equals num1 plus num2, and that's a math operation. And then what we want to do is display sum to the screen. So that's how it looks in pseudocode. In the flow chart, it works very much the same way. So we're going to have the begin here and the end icons to be the same. So they're rectangles, but with kind of oval shaped. They're really extended out because I just wanted to make this very usable and very seeable for those of you who are watching the video. And then I want to use some other structures, just very basic, so that we understand the flow of the code. So the next thing we do up here is use the parallelogram, and that's the icon that we're going to use for displaying elements to the screen. So the first thing we want to do is say this program adds two numbers together. Then inside the code, inside the program, we're going to create those 3 variables, num1, num2, and sum, and assign them variables. Then we're going to do the operation. Then we're going to display the output, and then we're going to end the program, and that's it. So with that being said, that's the pseudocode, and that's what the flow chart looks like in that order. And you can see that each of the arrows points down because the direction or sequence or flow of the data flows from one point to the next point to the next point, not going any other direction. We're just doing one thing after the other. The computer is going to read each line of instruction as it is and then execute it. So with that being said, let's take a look at this in code. So I said the first thing we want to do is actually print something out to the screen. So we want to say this program adds two numbers, okay? And we said that because that's what I wanted to say in the challenge. We want to make sure that everybody knows that whoever's using the program, that this program adds two numbers together. So I'm going to tell people that. Then what I said is we're going to create 3 variables, num1, num2, and sum. And then each of these variables will have a specific assignment, 3, 4, and 0. But we know that the variable sum is going to change because we're going to add num1 and num2, and then that now, whatever that math operation is, will be assigned to sum, and then we're going to just print it or display it to the screen. And in this case, when I say display to the screen, you're going to see the bottom section of my screen populate with some information and the answer. And that's called the console or the terminal. And that's only because I'm using Visual Studio Code as my platform. But that's neither here nor there right now. What we want to make sure is that this information is what the students are learning to think about and write down on the player sheet. So specifically, we have 1, 2, 3, 4, 5, 6, 7 lines of code. Well, actually not. We don't actually need this print statement. Only I have that here only because it looks better when it populates to this console, and we'll see why. So if I go ahead and run this, we're going to see that all this did is this program adds two numbers. So it reads this out, which is good. Now, all this other stuff is not really important in terms of the code. This is just because I'm using this particular coding platform to write my code in. So it's not really that important in terms of the learning experience, because you could use any Python editor or any Scratch editor, and we're still going to get the same code and we're still going to get the same output. Okay, it's just going to look a little bit differently. This print statement means that I just have an extra line, an extra space right here, but I am printing the sum. And so we can see that the computer knows specifically that these two variables, 3 and 4, are both integers. Okay, I and t means integer. And 3 plus 4 is equal to 7. And that's exactly what it prints out. So that's code challenge number 1. Let's go to code challenge number 2. I'll see you there.